Question 9 from May-June 2022. You have 4 questions to solve. On 9.3, you have 3 sub-questions. The total is 23 marks. Let's get started on the next slide. Let me get the question again. Question 9 from May-June 2022. Okay, this is the question. Question 9 sketched below is the graph of f of x is equal to x cubed plus ax squared plus bx plus c. The x-intercept of f are at 3, 0 and m, where m lies on the negative x-axis. K with this coordinate 0, negative 3 is the y-intercept of f. M and n are the turning point of f. Okay, now question 9.1. Show that the equation of f is given by f of x is equal to x cubed minus x squared minus 5x minus 3. This question is 5 marks. So the standard form of the equation of a cubic graph is this one. Okay, this is the standard form of the equation of a cubic graph. Now, since you know your x-intercept, it will be easy for you to choose this equation. This equation, which I'm going to call the vectored form. Okay, this is the vectored form. Since you know your x-intercept, it will be easy for you to choose this vectored form. So f of x is equal to, remember a that you have there, and this a is the coefficient of x cubed. Now, your x cubed, the coefficient is 1. Forget about this a that you are given there together with x squared. You might be confused. In our equation that we have here, your a is the coefficient of x cubed, which is 1. The coefficient of x cubed is 1. It is not this a. Forget about this a that you are given together with x squared. Okay, so the value of a is 1. As you can see, the coefficient of x cubed. Now, you need 3 x-intercept. Okay, you need 3 x-intercept so that you can get the x coordinate and you plug in there. You have the x-intercept and the turning point. This tells you that you have 2 x-intercept with the same values and you have another x-intercept there. So 2 and 1. So you have 3 x-intercept. So you are going to use the 3 x-intercept, you plug in there. Okay, so you have x minus the first x-intercept is m. So the x-coordinate of point m, we are going to call it xm. Okay, this is still our second x-intercept. Okay, so you're still going to have x minus the x-coordinate of this point, which is the x-intercept, still xm. Let's carry on. Minus, now you have 3. You carry on, f of x is equal to, you have 1 times this, you can put it like this, square, right? This times this, you have this squared, and then times this. So how can you get xm? You are going to use another point which is on the graph of f. Do not use your x-intercept. Use another point which is on the graph of f. Okay, we can use this point. So y is equal to negative 3. This is equal to x is 0, so you have 0 minus xm square. You have 0, x is equal to 0 minus 3. Okay, so we have used point k. So k is a point on the graph of f. Okay, let's carry on. You have negative 3 is equal to, you have negative 3 times this. So this is negative xm squared, right? It's positive. So you have negative 3 times this. It's positive xm squared. You are going to divide by negative 3 on both sides. By negative 3, you have 1 is equal to, by negative 3, you have xm squared. Now xm is equal to plus or minus square root of 1. xm is equal to plus 1 or minus 1. Remember, xm, the x-coordinate of point m is negative, right, on the negative side. So xm, the x-coordinate, it's negative 1, not positive 1, because we are on the negative side. You are even told where m lies on the negative x-axis. Okay, now you have xm. you are going to take xm, you plug in there and try to get f of x is equal to this. Okay, f of x is equal to, you have 1 x minus 1. Okay, minus 1, which is plus 1. X minus 1, right? xm is equal to minus 1. So you have minus 1, which is plus 1. And you have this. Okay. So f of x is equal to 1 times this. You still have this. So you have x times x, which is x squared. And then x times 1, which is x. And 1 times x, which is x. So you have x plus x, which is 2x. So you have plus 2x. Okay. And then you have 1 times 1, which is 1. So you have plus 1. You close the bracket times this bracket. Now we are going to multiply by this bracket. Okay, f of x is equal to x squared times x, which is x cubed, x squared times negative 3, which is negative 3x squared. Okay, so we are done with this. Now we are going to take 2x times x, which is plus 2x squared, right? And then 2x times negative 3, which is negative 6x. We are done with 2x. Now you can take 1. You have 1 times x, so plus x. And then 1 times negative 3 minus 3 or negative 3. Okay, f of x is equal to x cubed. These are like terms, right? Negative 3x squared plus 2x squared, which is negative x squared. These are like terms, negative 6x plus x, which is negative 5x. And then minus 3. Okay, so you can see f of x is equal to this. We have proved that f of x is equal to this. Okay, now let's move on to question 9.2. 9.2, calculate the coordinate of n. This question is 5 marks. So you have this turning point and this turning point. N is the turning point. Because n is the turning point, and to find the x coordinate of the turning point, we are going to use the first derivative. Okay, at the turning point, the first derivative is equal to 0. This is f of x, right? This is the graph of f. At the turning point, f prime of x is equal to 0. At the turning point, you have f of x, the equation of this graph. We need to get f prime of x first. Okay, f prime of x is equal to 3x squared. I hope you know how to take the derivative. Minus 2x minus 5. Okay, I hope you know how to take the derivative. And then minus 0. Okay, if you are still struggling on how to take the derivative, please check lesson 2 of 6 on calculus grade 12. Now we are going to make it equal to 0 so that we can get the x coordinate of this point. Okay, this is f prime of x. We make it equal to 0 and we solve for x. Okay, so we can factorize this like this. Okay, you have 3x times x. This will give you 3x squared, and you have negative 5. You can have 5 there and 1 there. Okay, and you are going to have 3x times 1, which is 3x, minus 5x, which will give you minus 2x. So you have to write minus there and plus there. So from this, x is equal to, you take this to the other side, you have 5 over 3, or x is equal to negative 1. When you take this to the other side, negative 1. So you have two x coordinates of the turning point. Negative 1 is for this m, right? On the negative side. Negative 1 is for this, and this is for n. The x coordinate is 5 over 3. So the coordinate of n, you have 5 over 3, and your y coordinate, To get the y coordinate, you are going to take this x value, you plug in the equation of the graph of f. Because n is on the graph of f, you are going to take this value, you plug in the equation of the graph of f. This is the equation of the graph of f. So you are going to take f of 5/3. So let's use our emulator. We are going to take f of 5/3. Okay, f of 5/3. You have x cubed. So you have 5/3 cubed minus x squared. So 5/3 squared minus 5x x is 5/3 minus 3. So you have negative 256/27. Negative 256/27. Okay, so these are the coordinates of point N. Now let's move on and do question 9.3. Okay, 9.3, for which values of x will 9.3.1 f of x less than 0. This question is 2 marks. F of x is less than 0 where f is below the x-axis, but not where f is touching the x-axis, right? F of x less than 0 means f of x negative or f of x below the x-axis. Okay, you have your x-axis there, and you can see the graph of f is below only at this part, but not there. At the point M, the graph is touching the x-axis. So you are only interested in below or negative, right? This is negative or below, not at this point. At this point, the graph is equal to 0. Okay, only this, you exclude this, and you have this. Okay, so you have all these values less than 3, but you exclude negative 1. This is negative 1. Remember from the previous question. So all these values less than 3, but you exclude negative 1. The graph is below the x-axis, or the graph is less than 0, or the graph is negative. Okay, so x less than 3, but x is not equal to negative 1. You can also give your answer like this. Less than negative 1, the graph is below, or the graph is less than 0, or the graph is negative. And you have this part between negative 1 and 3, the graph is below, or the graph is less than 0, or the graph is negative. Okay, between negative 1 and 3, negative 1 and 3. You can also give your answer like this. X element of from negative infinity up to negative 1, right? Negative infinity up to negative 1, or from negative 1 to 3. So you have 3 options, this or this or this. Either of them is the correct answer. You can give this one or this one or this one. Okay, now 9.3.2, for which values of x will f be increasing? This question is 2 marks. Okay, f increasing, you are going to look where is the graph going up. You have this part and this part. Okay, increasing means where is the graph going up. So you have this part and this part. So you have x less than negative 1. This is negative 1. Remember from the previous question, x less than negative 1, the graph is increasing, and x greater than 5/3, the graph is increasing. Okay, x less than negative 1 or x greater than 5/3, right? 5/3. You can also give this answer like this. X element of from negative infinity, right? From negative infinity all the way to negative 1. The graph is increasing, and from 5/3 all the way to positive infinity, the graph is increasing. Okay, so you have 2 options here. You can give this one or this one. Now 9.3.3, for which values of x will f be concave up? This question is 3 marks. You can see from there, up to this point somewhere there, the graph is concave down, and after that, the graph is concave up. So you don't know the point of inflection. You don't know the x-coordinate of the point of inflection. You need to get the x-coordinate of the point of inflection. You can get the x-coordinate of the point of inflection like this. Let me show you. To get the x-coordinate of the inflection point, you can use this method. You take the second derivative, you let it equal to 0, and you solve for x. The x-coordinate will be the x-coordinate of the inflection point. Or if you know your x-coordinate of the turning point, if you know your turning point, you can use this formula. Okay, I can use this, or you can use this. So I'm going to use this. So the x-coordinate of the inflection point is equal to, you have the first x-coordinate of the turning point is -1 plus the second x-coordinate of the turning point, the x-coordinate is 5/3. Okay, over 2. So the x-coordinate of the inflection point is equal to, you can use your calculator. Let me use my emulator. I have -1 plus 5/3. You divide by 2. So you have 1/3. Okay, 1/3. 1/3. You can also use this. You are going to find 1/3. So it's 1/3. Okay, which is somewhere there. So somewhere there you have the x-coordinate of the inflection point. So the inflection point is there. Okay, so now you can tell for x greater than 1/3 all these values. X greater than 1/3 or x greater than 0.3, the graph is concave up. Okay, so you can say x greater than 1/3, the graph is concave up. Or you can also give your answer like this: x element of from 1/3 all the way to positive infinity. Okay, so you have two options. You can give your answer like this or like this. Another way to solve this question, if you don't have the sketch, let's say you don't have the sketch. Okay, alternatively, if you don't have a sketched graph, how can you solve 9.3.3? Okay, 9.3.3, for which values of x will f be concave up? Still 3 marks. Okay, how can you solve this question if you don't have a sketched graph? What you have to do is to use the second derivative. With the second derivative, you can tell where the graph is concave up or where the graph is concave down. Okay, so you have the first derivative. Let's get the second derivative. The second derivative is equal to 6x minus 2. Okay, and then minus 0, right? Minus 0. So this is the second derivative. You are going to take the second derivative, you make it greater than 0. If you are requested to find where the graph is concave down, you are going to take the second derivative, you make it less than 0. Okay, and then you can now solve for the inequality. So you have 6x greater than, you take this to the right, greater than 2. You are going to divide by 6 on both sides. You divide by 6, you have x greater than. You divide by 6, you have 1/3. You can also give your answer like this, as we did here. Okay, so two options. You can use this method if you don't have a sketched graph. Okay, let's move on to question 9.4. 9.4, let me get the question again. 9.4. Okay, question 9. This is the question. Now it's 9.4. Determine the maximum vertical distance between the graphs of f and f prime in the interval from -1 to 0. This question is 6 marks. Okay, if you check from the previous question, f of x is equal to this. Okay, this is f of x from the previous question, and f prime of x is equal to 3x squared minus 2x minus 5. So you have the two equations, the equation of f and the equation of f prime. Okay, let's try and sketch the two graphs so that you can understand what the question is requesting from you. Okay, let me close this. So the two graphs, the graph of f, this is the graph of f that you are given from the question, right? You can see that the graph of f, this is the graph, right? The one in black, right? This graph. And the one in red is the graph of f prime. The question is determine the maximum vertical distance between the two graphs, the graph of f and the graph of f prime in the interval from -1 to 0. In this interval from -1 to 0. Okay, so this is the graph of f of x and this is the graph of f prime of x, right? The one in black is the graph of f and the one in red is the graph of f prime. Now you need to determine the maximum vertical distance between the two graphs. Okay, this is the equation that you have to use to determine the vertical distance. Okay, first you need to get the equation that you are going to need to determine the vertical distance. The equation of vertical distance is equal to always the equation of the top graph minus the equation of the bottom graph. Okay, in this interval from -1 to 0, you can see the top graph is this one, the one above in this interval. You have the one in black, which is the graph of f, and the bottom graph is this one, the one below, right? Bottom below, you have this one in red, which is the graph of f prime. So you need to determine the equation of vertical distance first. So the equation of vertical distance is equal to the equation of top graph, which is this one in black. Which one is it? F of x. This one. Okay. Minus the equation of bottom graph. Bottom graph, the one in red, which is this one, f prime. Make sure you put everything in bracket because this negative is going to affect everything there in bracket. So you make sure you close everything in bracket so that you don't make a mistake because the negative there is going to affect everything there because you have minus the equation of bottom graph. This is the equation. So this is equal to x cubed minus x squared minus 5x minus 3 minus 3x squared plus 2x plus 5, right? Because you have a negative there. So you have this. This is equal to, you have your log terms. You have x cubed. Your log terms are this and this. Negative x squared minus 3x squared, which is minus 4x squared. And you have this and this. Negative 5x plus 2x, which is negative 3x. And you have this and this. Negative 3 plus 5, which is plus 2. Okay, so this is the equation of the vertical distance. You have so many vertical distance on this interval from -1 to 0. From -1 to 0, you have so many vertical distance. You can have this, you can have this, or you can have this, or you can have this. All these are vertical distance. So you can draw many. I have only 4 of them. 1, 2, 3, 4. You can draw many. You are interested to find the maximum vertical distance. These vertical distance, they are not the same distance. You have some, they are short, some, they are long. You are interested to find the maximum. You are interested to determine the longest, okay, maximum, the longest vertical distance. Now, this is now when calculus becomes useful. You are going to get first the x value, which is going to give you the maximum vertical distance. You need to get the x value in this interval from -1 to 0. That x value will give you the maximum vertical distance. This is now when you are going to use calculus. Okay, get the x value that will give the maximum vertical distance. How can you get that? You are going to take the derivative of this with respect to x. You're going to take the derivative of the vertical distance with respect to x. Okay, so you're going to take the derivative of this whenever you are interested to find the maximum or minimum value. You have to take the derivative with respect to some value, in this case to x. Okay, so the derivative of the vertical distance with respect to x is equal to, this is equal to 3x squared minus 8x. I hope you know how to take the derivative minus 3 plus 0. So you have this. You are going to equate it to 0 and you solve for x. That x will be the x that will give you the maximum distance, the maximum vertical distance, or the longest vertical distance. So let's get the x value. You have to equate this to 0. You equate it to 0 and you solve for x. You are going to factorize this. You factorize. So you have 3x times x, and you have, this is negative 3. You can put 1 there and 3 there. You need to have, this is 3x times 3, which is 9x. You need to subtract. So you are going to have 1x, right? 1x minus 9x will give you minus 8x. So you are going to have plus there and minus. Okay, so x is equal to negative 1 over 3, or x is equal to 3. Okay, you can see x is equal to 3 is not in this interval, right? You are only interested in this interval from negative 1 to 0. So only this value falls in there. So you are going to use this value because it falls in this interval. You are going to take it, you plug inside the equation of the vertical distance so that you can get your maximum vertical distance. So the maximum vertical distance is equal to x cubed. X is equal to negative 1 over 3, right, in this interval. Negative 1 over 3 cubed, negative 1 over 3 cubed minus 4x squared. This is x squared minus 3x. X is this plus 2, right? This is equal to, plug this in your calculator. I'm going to use my emulator. So you have this 1 over 3, right? Negative 1 over 3 to the power of 3 minus 4 times negative 1 over 3 to the power of 2 minus 3 times negative 1 over 3 plus 2. This is equal to 68 over 27. Okay, 68 over 27. This is equal to, you have 2.52. Okay, 2.52. Right, 2.52. So this is your final answer. This is the maximum vertical distance on this interval. Okay, so we are done with question 9 from May, June 2022. Okay, until next time, I will talk to you soon.